Hello everyone. In this tutorial, we will learn the artificial neural networks. So, in the in this first paragraph, we basically define the ANN structure, and I can give you a brief idea about that, and a brief and compact idea about the ANN structure. So that is ANN structure basically inspired by biological neurons, made of interconnected units, artificial neurons basically organized in layers. And the layers part, basically it has input layer, hidden layer, and an output layer. So the input layer receives external data, and hidden layer and transform the data, and output layer basically produces the final result. And connections between units have weights that influence the information flow, as we saw in our past videos. So the learning process, basically data flows through layers and weights are adjusted to improve the network's performance. And how do artificial neural networks learn? So so basically artificial neural networks, basically how we train that, we discuss about that. Basically the ANNs learn from labeled examples, like here we take the cat image basically, for an example, and forward pass data flows through the network making initial predictions. And after that we basically check the errors. I mean the error checking part, that is predictions are compared to the correct labels, that is human provided. I mean we give them. And after that the back propagation errors are used to adjust connection weights, I mean the fine tuning part, and iteration training continues until the ANN achieves our desired accuracy. So after that, what are the types of ANN, artificial neural networks exists? So as you can see that feed forward neural network, that basically the feed forward neural network is the most basic ANN network. In this ANN, with the data or the input provided uh, travels in a single direction. It enters into the ANN through the input layer and exits through the output layer, while hidden layers may or may not be exist. And so the feed forward neural network has a front propagated wave only, and usually does not have back propagation. And after that the CNN, convolution neural network. Convolution neural network has some similarities to the feed forward neural network, where the connections between units have weights that determine the influence of one unit or another unit on another unit. But a CNN has one or more than one convolution layer that uses a convolution operation on the input, and then passes the result obtained in the form of output to the next layer. And CNN has applications in speech and image processing, which is particularly useful in computer vision. And the next part, and next and most important in the current days, as we can see the improvements of generative AI. So the RNN part, near recurrent neural network. The recurrent neural network saves the output of a layer and feeds the output back to the input to better predict the outcome of the layer. And the first layer in the RNN is quite similar to the feed-forward neural network. And the recurrent neural network starts once the output of the first layer is computed, and after this layer each unit will remember some information from the previous step, so that it can act as a memory cell in a performing computations. So now we see the what is gradient descent. Gradient descent basically means, uh, gradient descent basically, uh, basically it's an optimization algorithm for minimizing the functions, and it works by iteratively moving the in the direction of steepest descent. I mean the opposite of the gradient. And it basically, this gradient basically indicates the direction of greatest increase or decrease. And here our goal is to reach in a minimum, I mean where the gradient is zero. And it basically used to train various machine learning models. And how does this gradient descent work? Gradient descent basically, gradient descent works basically, it's a basically iterative optimization algorithm for functions. And it updates the parameters to minimize the cost function, I mean the error part. and uses the gradient to guide updates, and it includes the steps like initialize the parameters, calculate gradient descent of cost function, and then update the parameters in the opposite direction of the gradient. I mean, that decrease the cost, and after and finally it basically repeats the second and third until the convergence of where the minimum reached. And it's basically commonly used for technique training machine learning models. And after that we see some basically we want to implement the gradient descent in TensorFlow, and we need to define the cost function that we want to minimize. So this code basically demonstrates that code basically uses the TensorFlow 1 and TensorFlow 2 introduced in significant changes. So this ensures compatibility and with I mean the older code examples. And you guys might encounter TensorFlow versions online as well. And I mean, after that we basically defining the placeholders in this for with this line: x equal to tf dot placeholder and y equal to tf dot placeholder. And this line defines placeholders for the input data x and the target output y. Think of this as empty slots where you will feed your actual training data during the training process, and just specify the data of the will be floating point numbers. And after this line we basically model our parameters, and with w equal to tf dot variables. And this line defines a variable named w with an initial value of zero point 0.5, and this variable represents the weight in our simple linear regression model, which we will adjust during training. And variables in TensorFlow can be updated during the learning process. And after that we building our linear model, and basically this line tf dot add equal to tf dot add, basically model equal to tf dot add. This line basically defines the linear regression model itself, and it multiplies the input x by the weight w and adds a bias of zero point 0.5. And this represents equation of straight line and where we trying to fit our data. And after that we defining our cost function, that is that what we want to minimize. And cost function, basically this line defines tf dot reduce underscore mean. And this line defines the cost function, also called the loss function. It basically calculates the mean squared error between the model prediction and the actual target values. The MSc targets how far our model's prediction are from the true values on average. And after that we creating the optimizer in this with this line. And after that we basically minimizing our cost, that is optimizer dot minimize. This line defines the training operation. It basically instructs the optimizer to use gradient descent to minimize the cost function by adjusting the model's weight based on the calculated gradients. And here we take the sample data set, this thing. We take the sample data set, and we basically running that training. And TensorFlow, it basically creates a TensorFlow session. And after that we basically execute the computational our graph. And the for loop part in this code, the for loop, this part, we basically here what we do here. The for loop iterates over for 1,000 training steps. And it this line with this line I mean the w dot assign, that part. Yeah. So that part we this line runs the training operation train and feeds the actual training data and into the placeholders. And this is where our learning happens. So after the training, the code doesn't explicitly print the learned weight w, but it would represent the slope of the line. And the model has learned to fit the data. So here we will learn the implementation part of the gradient descent and many more things. So thank you guys.